Hello class. So today we're going to learn about the chain rule. Okay, let me see here. The chain rule is this part here. Okay, so here we go. So for the chain rule, it is suppose YF composite of U is a function that is a composite of f is differentiable at u gx and u gx is differentiable at x. I know this is a bit hard to understand in words, so I think it's better we have some example. Okay, so let's say we have this function fx is cos x and gx is, and the function gx is 4x. So what does it mean by f gx composite into fx is, okay, rewrite back the function for fx, which is cos x, but in x part you have to put in 4x. Okay, so for this kind of function, can we use the product rule? No, we can't. Okay, because this is a composite function. So for composite function, we have to use the chain rule, which is here. The equation is here. There is two types of formula on how to solve composite function kind of equation, and for today we're going to learn both method. Okay, let's say here we have, for example 10. Okay, that's not okay. Let's say here for example 10, y equal to cos 4x. Okay, now we're going to learn how to use the first method first, which is this one. Okay, y cos 4x. So u here it can be segregated into two functions, which is y and u. U. Okay, so for y is this part here can be represented as u, right? So it should be cos u, because we call it u now, right? Okay, so differentiate against u, dy du, y prime, differentiate cos u, you will get minus sin u. Okay, now we're going to differentiate the second part, which is 4x. U equal to 4x, and then differentiate against dx. Du dx or u prime is 4. So according to this method, what you should do is dy dx equal to dy du, which is this one here. Dy du is minus sin u times du dx. Du dx here is 4. So for this one, it is minus 4 sine u. But please do not forget, for the final answer, you have to replace u with 4x. Again, okay? 4 sine 4x. So this should be the final answer, because what we want to do here, we want to differentiate it against dy dx, not dy du only. Okay, that's why. Okay, so now we're going to learn how to use the second method. Okay, for second method, y equal to cos x. Okay, second method, first you derive the first function that you see from the left. The first function that you see from the left is cos x. Cos. Okay. So can be written like this. Okay, first function from the left. Sorry, cos 4x here. Okay. Okay, first function from the left, you will see is cos 4x. So differentiate the whole thing, cos 4x, and you will get what? Class minus sine 4x times with the second function. What is the second function here? The second function here is 4x. Okay, g prime x is, okay, so gf here is cos 4x and g here is just 4x. So differentiate 4x, you will get 4. So the final answer is this one. Okay. Okay, I hope you can understand this. So for the second method here, for the b here, we're going to use the second method again. So b is y equal to tan sine x. What we should do? Differentiate the first function you see from the left, which is tan, and just let the anything on the second function, just let it be. Okay, as you can see in the formula here. Okay, differentiate tan and you will get second square, and rewrite back the second function, gx is sine x, and you should differentiate gx to be g prime x. So differentiate sine x, you will get cos x. Okay, easy peasy, right? Okay, class, I was talking to myself just now because I did not realize that I haven't turned on the record function. So for this one here is y equal to third x square plus 1, which can be rewritten like this, x square plus 1 to the power of half. And then what you should do is you should differentiate the function, the overall function first, okay, which is f prime. So differentiate this, half brought to the front, and this half minus 1 times with the differentiation of the function inside here. Okay. Okay, so what the thing that is inside here is this x square plus 1. So differentiate this part here, you will get this, and differentiate ddx of x squared plus 1, you will get 2x. So this should be the final answer.